Hey everybody, it's time for another video. Today we're going to learning, and what I'm going to do is, in this case, is you're going to write today's date. Today's date is going to be 3/7/2012. And at the top, you're going to write basically, or we're going to write different standards in this, so you're going to follow along and write this down. First of all, this is a little bit of a review, but maybe some of you need, essentially additional guidance. The one thing about finding limits that we want to do, is direct substitution. Okay, we want to do substitution. It's the easiest one. So, for example, again, sorry, it changes all my arrows to these little R signs. But this one says find the limit as it goes to 2. And if I plug in 2, I get 9 up the top, I get 1 on the bottom, I get 9. So, in essence, I want direct substitution. Or in this case, this one says as x goes to -1. I want to plug in -1, which gives me 1 minus 1. I get -6 on the bottom, which gives me 0 over -6, or 0. So direct substitution is our friend. Okay. And again, you could sort of cancel this out. Okay. But we're just going to review a little bit if you remember how to do things like this. And again, I was gone, so maybe another video will help you out. Okay. If you get direct substitution and you get 0 over 0, or in other words, indeterminate, essentially there's a hole in the function, and you need to factor and cancel and eliminate. Anytime you get 0 over 0, that's a hint for you that you need to simplify it somehow. This first one is review, and then the next two ones we'll go over again because some of you said you had a lot of difficulty. So this one's going to be, this one that says factoring, this one's going to be standard 2.2. So write for me standard 2.2. Okay, so this is standard 2.2. Finding limits by factoring. So here it says as x goes to 3, right? But if I plug in 3, I get 0 over 0, okay? Which means, hey, what the heck's going on? I need to figure out, there has to be something to simplify here. So what I'm going to do is I'm going to factor this. You notice at the top I have difference of squares, and this might be a review for some of you. At the top, because it's difference of squares, I could write this x plus 3, x minus 3. And if you have difficulty doing difference of squares, I can help you out a different time. Okay. Now I notice that there's an x minus 3 on the top and on the bottom. Which means this whole problem really just means x plus 3. Now that I've canceled out something, now I could go back and try plugging in 3 again. If I plug in 3, 3 plus 3 equals 6. So that is the limit as x approaches 3. Okay. Same thing with this one down here. If I plug in -2, just to take away the surprise or the spoiler alert, if I plug in -2, I get 0 over 0. So that tells me I got to factor. This top part, I could factor it x plus 2, x plus 1. Okay. On the bottom, it's another difference of squares, so x plus 2, x minus 2. What do you notice? Yeah, I have an x plus 2 on the top and the bottom. Okay. So this whole problem can just be rewritten as x plus 1, x minus 2. And if I plug in a -2 now, I get a -1 over -3, or 1/3. And I could do more factoring for you guys. I think we've done enough. I think you guys are comfortable with it. You guys did it on your midterm, so I'm not going to do any more of that. Now, to the stuff that you guys really want help with, and this is rationalizing. And some of you may be very angry and confused about how to do rationalizing. Okay? Very first things first, remember step 1 is always try direct substitution. We want to do that. If I plug in 4 at the numerator, I get 0. Plug in 4 in the denominator, I also get 0. That means, man, I gotta simplify. Okay? You should know how to factor the top. It's 3x minus 4. And on the bottom, I have nothing to do, or it stays like this. Nothing cancels top and bottom, and if I plug in 4, I still get 0 over 0. And some of you may be saying, what gives? This is standard 2.3. So maybe you could write it right next to here. Standard 2.3. Solving limits by rationalizing. Okay. What I'm going to do is, I notice I have a square root. It doesn't have to be in a denominator necessarily. It could also be in the numerator. But if I notice something like this, I will multiply by the conjugate, which is in this case 2 plus radical x. In calculus, you never really multiply anything out, like FOIL it, unless it actually is a conjugate. So the numerator will stay like so. So all I did by multiplying the conjugate, all I did was multiply across. In the denominator, I do have conjugates, so I want to FOIL this out. Since they're conjugates, remember all I care about is the inside and the outside. So 2 times 2 is 4. And minus radical x times positive radical x will just be minus x. Here's where you're going to get confused, and I remember, I believe it was Matt that mentioned, what the heck? It almost looks like it's matches, but it doesn't really match up. I can't really cross it out yet. These look very similar. Okay. What I can do, it doesn't matter which you want to do it on, but let's just say in this numerator, let's factor out a negative 1 out of this x minus 4. What happens if I take out a negative 1 from this? Okay. If I take out a negative 1, this will become negative 3. This becomes minus x, and then this becomes plus 4. So do you see how these now are exactly the same when I took out a negative? So what was once 3x minus 4 is now negative 3, negative x plus 4. All I did was change the signs of everything in here and move the negative out in front. Now I notice that I have a factor on the bottom and the top that can cancel out. This whole problem is actually just negative 3, parentheses, parentheses, 2 plus radical x. Now that something canceled, remember when something cancels, let's try direct substitution again. And now when I plug in 4, the square root of 4 is 2. 2 plus 2 is 4. 4 times negative 3 is negative 12. Okay. This problem, same thing. If I plug in a 0, spoiler alert, you get 0 over 0. Okay. I notice that I have a square root in this problem. And I notice I can't factor anything, so I'm just going to multiply by the conjugate. Okay. So let me see if I can delete this. Oh, there you go. And let's multiply by the conjugate, which in this case is going to be square root of x plus 1 with a plus in the middle, 1. Square root of x plus 1 with a plus in the middle, 1. Let's multiply this out. At the top, I got conjugates, so all I care about is multiplying these ones and these ones. Square root of x plus 1 times square root of x plus 1 is x plus 1. Negative 1 times positive 1 is negative 1. In the bottom, I don't have conjugates, so I'm just going to leave it alone. Okay, so far? And now, nothing really cancels yet, but I do see two things. You see I have a plus 1 and a minus 1 on the top? Those cancel. And then, once those cancel, I just have an x up at the top, and now I have an x on the bottom. So now these x's cancel. The whole problem just becomes 1 over the square root of x plus 1 plus 1. Since something canceled, now I could try plugging in the 0 again. And when I plug in 0, I get the square root of 1, which is 1, plus 1. The answer is going to be 1/2. And let me box the last answer too. So that's basically it about rationalizing. Anytime you see a square in the problem, all you do is multiply top and bottom by the conjugate, and something should cancel. It's very rarely where you do the conjugate and nothing cancels. I don't think I am or the books are evil enough for you to give you a problem where nothing cancels top and bottom. The last one, and probably your least favorite one, is what they call fractions or fractions in a fraction. I get it. Not a lot of you like fractions. Okay. So in this first one, it says as x goes to 0, and when I plug in 0, here I get 1/3 minus 1/3, which is 0. If I plug in 0 in the denominator, I get 0. 0 over 0. What the heck? I gotta simplify this. Can't factor. Can't multiply by the conjugate. There's no square root. What do I do? And some of you are gonna hate this. And some of you already hate this. Okay. What you're gonna do is, anytime you have a fraction, is I need to combine the fractions. I want to get this fraction just turn into just 1. So let's multiply by, or let's try to get a common denominator. So this one I'm going to multiply top and bottom by 3. This one top and bottom I'll multiply by 3 plus x. So what I'll get on the top now is going to be still x on the denominator. Here I'll get 3 plus x, and here I'll get minus 3 plus x over, oh sorry, this should be 3 plus x, 3 plus x. Okay, so far? So all I did was find a common denominator. Top and bottom by 3, here's my 3's. Top and bottom by 3 plus x, here's my 3 plus x's. Now that my denominators are the same, and again, don't FOIL this or distribute this because you never have to in calculus unless you're like doing conjugates or whatever, so don't do it. Now that I have a common denominator, now I can distribute this minus and subtract across the numerator. So what I'll get is my big denominator, still x, and here I'm just going to subtract across. 3 minus x. And the biggest problem that I see is that when you subtract this minus 3 plus x, you have to distribute this minus. You're subtracting 3. You're subtracting 3 and you're subtracting this x. Okay? So that's where I get this negative 3 minus x. Okay. Up at the top, you may notice this 3 minus 3. Since I have a 3 minus 3, this cancels and this cancels. And this whole problem is just negative x, 3 plus x, all over again, x. Okay, so far? We've done a lot of practice of this in honors pre-calculus. I have a fraction within a fraction. What I'm going to do is that x technically can be written as x over 1. Since I'm dividing fractions, remember what I can do is I could flip and multiply. So instead of saying this, I can call it this, where I flipped my denominator and did a multiplication. You may notice now that I have an x up at the top and an x on the bottom. Those will cancel. So this whole fraction, this gigantic mess at the top, can actually just easily be written as negative 1 over 3 plus x. That rule that I keep telling you, now that you've canceled something, I could plug in the 0 and get an answer. 3 plus 0 is 3. 3 times 3 is 9. So instead of getting 0 over 0, now I actually get an answer. Yay. Okay. So that is how you do that. And the last problem for this video lecture is this one right here. Got fractions again. Anytime you have fractions, you got to find a common denominator. Alright? Here, not common denominator yet, but I'll notice that in the denominators for both of them, they're both factorable. So before I even start finding the common denominator, let's rewrite these. This can be written as 3t minus 2, factoring out a 3 from both 3 and 6. And on the other side, I have a difference of squares on the bottom. T plus 2, t minus 2. You may notice that there's not so much now that I need to do to get a common denominator. This one just needs a t plus 2. So top and bottom, multiplying by t plus 2. And I got that, so I get a common, the same denominator as this one. This side needs a 3. So I'll multiply top and bottom by 3. Let me delete this real quick. Or not. I'll just move it up here then. Oh, never mind. So now I've multiplied and I've got a common denominator. At the top here, I have 3 t plus 2 with that nice denominator on the bottom. Over here, I'm going to get 12, 3 t plus 2, t minus 2. So I got the exact same denominator. Now I could just subtract across. Okay. So now when I subtract across, I get 3 t plus 2 minus 12 all over 3 t plus 2 t minus 2. Aha! So close. Okay. Now, some of you may be tempted to do a couple things. Some of you may want to cancel these 3's out. You can't do that yet. Some of you may want to cancel these t plus 2's. You can't do that yet. Okay, you have to have basically a common or a common factor for you to. And this one, if this had a 3 and there's a 3 over here, then yes, you could cancel it. But right now, you can't cancel out anything. Okay. So what I'm going to do is let's multiply this out right here. Okay, this looks like it's sort of a little messy. Let's multiply it out now. I'm going to get 3t plus 6 minus 12. And let me just delete this or move it over so I get some more space. Okay. This one up here simplifies to 3t minus 6 hopefully y'all are still okay. So all I did was made this a minus 6. Still nothing I could cancel out. But I notice here in the numerator, this can be factored again. I know it's a long problem, but you can do this, okay? I can factor out a 3. Now I could cancel something, and now I can look at things on top and bottom and see what I can cancel. Do you guys see stuff that I could cancel? Yeah, 3 on top, 3 on bottom. T minus 2 on top, T minus 2 on the bottom. This whole thing, oddly enough, that giant mess that we've been working on, all means the exact same thing as 1 over T plus 2. This whole thing means the exact same thing as everything we've just been working on. It's 1 over T plus 2. Now that stuff cancels, remember the rule I keep telling you, once something cancels, we can start plugging it in. If I look at my original problem, it says T goes to 2. So now I can plug in 2. My answer is going to be 1/4. So we'll spend some time practicing how to rationalize and also simplify fractions with simplify limits when they have fractions in the fraction. So also, if you still have some space, this is standard 2.3. Wait. This is standard 2.4, sorry. So for homework, you've watched this, you're going to answer the quiz questions below, and the new starting tonight, you need to post a discussion post, this little reflection, either one, what you learned in class, or maybe what you learned in class, and also from this video, what are some of the things that you have difficulty on, that you need help with, that we can go over in class or whatever. So hopefully you enjoyed it. I know it's a 17-minute video, so some of you are going to complain. But hey, the homework was so short, it only takes 17 minutes. See you guys in class, and see you later.